Imagine waking up one morning and realizing that almost every major breakthrough in artificial intelligence is running on technology built by a company most people barely noticed a decade ago. From ChatGPT to self-driving cars, medical research, robotics, scientific discovery, and the world's largest AI supercomputers, one name sits quietly behind them all: NVIDIA. Today, it's one of the most valuable companies on Earth. The biggest AI companies rely on its hardware. The world's leading researchers depend on it. Even many of its competitors build their products around NVIDIA technology. But this wasn't an overnight success. NVIDIA didn't suddenly appear when AI became popular. It spent more than 30 years solving problems that most people didn't even know existed. By the time artificial intelligence exploded into the mainstream, NVIDIA had already built the foundation it needed. To understand how that happened, we have to travel back to Silicon Valley in 1993. The internet was still young. Mobile phones were rare. Artificial intelligence existed mostly inside research labs, and computer graphics looked primitive compared to what we see today. Inside a simple Denny's restaurant, 3 engineers met over coffee: Jensen Huang, Chris Malachowski, and Curtis Priam. They weren't talking about artificial intelligence. They weren't trying to build a trillion-dollar company. They were obsessed with one question: how could computers generate realistic 3D graphics much faster than they could at the time? Back then, nearly all of that work depended on the CPU. It was flexible enough to perform many different tasks, but it wasn't designed to process millions of similar calculations simultaneously. The 3 founders believed computing needed something completely different, a processor built specifically for parallel work. It was a risky idea. The market for advanced graphics was still small, and many people doubted dedicated graphics processors would ever become a major business. But the founders saw a trend others missed. Video games were becoming more realistic every year. Hollywood demanded increasingly sophisticated visual effects. Engineers needed faster simulations. Scientists required more computing power. The demand for parallel computing was quietly growing. Most people saw better graphics. NVIDIA's founders saw the beginning of a new way of computing. Only a few months later, they officially founded NVIDIA with a clear mission: build the world's most powerful graphics processor. At first, that sounded like a company built only for gamers. But every improvement they made wasn't just making games look better, it was making parallel computing faster, more efficient, and more powerful. Without realizing it, they were laying the technological foundation that modern artificial intelligence would one day depend on. The world believed NVIDIA was building graphics cards. In reality, it was building the engine that would eventually power the AI revolution. But turning that vision into reality wouldn't be easy. The young company burned through cash quickly while competing in one of the fastest-moving industries in technology. By the late 1990s, survival, not success, had become the priority. Then one breakthrough changed everything. In 1999, NVIDIA introduced a graphics card called the GeForce 256. To gamers, it promised smoother gameplay and better graphics. But NVIDIA described it very differently. It called it the world's first graphics processing unit, the GPU. That wasn't just a marketing slogan. Unlike traditional CPUs, which handled tasks one after another, the GPU was built to perform thousands of calculations at the same time. That single design decision transformed gaming almost overnight. Developers built larger worlds. Graphics became dramatically more realistic. The entire industry accelerated. But hidden beneath that success was something even more important. The GPU wasn't just good at rendering graphics. It was exceptionally good at solving any problem that could be divided into millions of parallel calculations: physics simulations, weather forecasting, medical imaging, scientific research, financial modeling, and eventually, artificial intelligence. Most people believed NVIDIA had created a better graphics card. In reality, it had quietly invented a completely new style of computing, and that was only the beginning. A revolutionary processor was only half the solution. The GPU had incredible computing power, but there was a major limitation. Only graphics applications could truly take advantage of it. Scientists couldn't easily run complex simulations. Medical researchers couldn't process massive datasets. Universities couldn't unlock its full potential. Outside the gaming industry, the GPU was like a race car without a steering wheel, powerful, but difficult to control. Jensen Huang understood that hardware alone would never change the future. If NVIDIA wanted to transform computing, developers needed a simple way to program the GPU for problems far beyond graphics. Most companies would have focused on selling faster graphics cards. NVIDIA made a much riskier decision. Instead of asking, "How do we build a better GPU?" they asked, "What if the GPU could solve almost any computational problem?" That question led to one of the most important software decisions in modern computing. In 2006, NVIDIA introduced CUDA, the Compute Unified Device Architecture. At first glance, CUDA looked like just another software platform. In reality, it completely redefined what a GPU could become. For the first time, developers could write programs that used NVIDIA GPUs for much more than rendering video games. The same hardware that generated realistic graphics could now simulate molecules, forecast weather, analyze medical scans, process financial models, and solve millions of mathematical calculations simultaneously. Almost overnight, the graphics processor became a general-purpose computing engine. Surprisingly, very few people noticed. There were no massive product launches, no headlines announcing the beginning of the AI era, only a small community of researchers, engineers, and software developers quietly began experimenting with something extraordinary. Year after year, that community grew. Universities started teaching CUDA. Research laboratories rewrote their software around it. Calculations that once required days suddenly finished in hours. Some workloads that once took hours were reduced to minutes. With every new project, NVIDIA's advantage became stronger. Its competitors continued building hardware. NVIDIA was building an ecosystem. Every programmer who learned CUDA, every university course, every research paper, every software library added another layer to an ecosystem that became increasingly difficult to replace. Without realizing it, thousands of researchers around the world were investing their time into NVIDIA's future. The company was no longer selling only processors. It was building a software moat. Years later, competitors would discover that copying the hardware was only the easy part. Replacing millions of lines of CUDA-based software, developer tools, libraries, and frameworks would prove far more difficult. Still, one challenge remained. Artificial intelligence had not yet entered the mainstream. Deep learning existed mostly inside universities and research labs. Many experts believed it was an interesting academic idea, but not a practical technology. The hardware was finally ready. The software was finally ready. Only one thing was missing: proof. That proof arrived in 2012. A small research team entered the ImageNet competition with a deep neural network trained on NVIDIA GPUs. Their model was called AlexNet. When the results were announced, the technology world was stunned. AlexNet didn't just win. It outperformed every competing system by a margin so large that researchers immediately realized artificial intelligence had entered a new era. Almost overnight, the question changed. People stopped asking, "Can deep learning actually work?" Instead, they began asking, "How quickly can we scale it?" That single breakthrough validated everything NVIDIA had been building for nearly 2 decades. Without creating the algorithm itself, NVIDIA had quietly built the computing engine that made the breakthrough possible. The AI revolution had finally begun, and NVIDIA was already standing at its center. The success of AlexNet didn't just change artificial intelligence, it changed NVIDIA forever. Researchers around the world rushed to adopt CUDA. Universities added GPU programming to their courses. AI laboratories began building larger and more ambitious neural networks, and every new breakthrough demanded even more computing power. NVIDIA had spent nearly 20 years preparing for exactly this moment. While most technology companies reacted to the AI revolution, NVIDIA had already built the tools it required. But Jensen Huang knew the next challenge wasn't simply building faster GPUs. The future of AI would require thousands of GPUs working together as one enormous computer. That meant the connection between those processors had become just as important as the processors themselves. In 2016, NVIDIA introduced a system that proved this vision. Its name was DGX-1. Unlike traditional servers designed for general computing, DGX-1 had one purpose: deep learning. 8 powerful NVIDIA GPUs worked together inside a single machine, tightly integrated with CUDA and specialized AI software. For the first time, researchers could purchase a ready-to-use AI supercomputer instead of spending months building their own computing clusters. NVIDIA was no longer selling graphics hardware. It was selling complete AI infrastructure. One of the very first DGX-1 systems was delivered to a young research organization called OpenAI. At the time, almost nobody noticed. Years later, OpenAI would introduce ChatGPT and help ignite the largest AI boom in history. It wasn't luck. It was another example of NVIDIA placing itself exactly where the future was being built. Then came another decision that looked ordinary at first, but proved just as important. In 2020, NVIDIA acquired Mellanox, a company specializing in high-speed networking. Many investors questioned the price, but Jensen Huang understood something the market hadn't fully realized. Training the world's largest AI models doesn't depend on a single GPU. It depends on thousands of GPUs communicating with each other at incredible speed. Without fast networking, even the most powerful processors spend valuable time waiting. With Mellanox, NVIDIA didn't just own the processors, it also controlled the communication system connecting entire AI supercomputers. The company had evolved from a chip manufacturer into a builder of complete AI ecosystems. From silicon to software to networking, everything working together as one platform. Then the world changed again. Generative AI entered the mainstream. ChatGPT introduced millions of people to conversational AI. Image generation tools amazed the public. AI coding assistants accelerated software development. Scientists used AI to speed up research. Businesses across every industry began racing to adopt the technology. Behind nearly every major breakthrough was the same ingredient: massive accelerated computing powered by NVIDIA. Cloud providers rushed to expand their GPU infrastructure. Technology giants invested billions in new AI data centers. Governments launched national AI initiatives. Demand became so overwhelming that NVIDIA's most advanced chips were often sold out months before production. The company, once known for gaming graphics cards, had quietly become one of the most important infrastructure companies in the world. By fiscal 2026, NVIDIA reported record-breaking revenue, with its data center business generating far more than its gaming division, a clear sign that artificial intelligence had become the company's future. Yet perhaps the most remarkable part of NVIDIA's story is this: it didn't build ChatGPT. It didn't create Gemini. It didn't develop Claude. It didn't launch Llama. Instead, it built something even more valuable: the foundation that made all of them possible. Just as steel companies enabled the skyscrapers of the modern world, NVIDIA supplied the computational engine behind the AI revolution. Quietly, patiently, for decades. But the story isn't over. NVIDIA still depends on advanced manufacturing partners, global supply chains, and some of the world's most sophisticated semiconductor factories. Geopolitics, energy demands, manufacturing capacity, and rising competition will all shape what comes next. History has shown that technology leaders don't remain on top automatically. They survive by reinventing themselves again and again. Artificial intelligence is no longer a prediction. It's already transforming the world. The next question is, who will build the machines powerful enough to drive the next generation of AI? If NVIDIA's history tells us anything, it's this: the company has never waited for the future to arrive. It has spent decades building it long before everyone else could see it. And maybe that's the greatest lesson hidden inside NVIDIA's story. The biggest revolutions rarely begin with the loudest announcement. Sometimes they begin with 3 engineers sharing coffee inside a small roadside diner, dreaming about a future that nobody else believed was possible.